Okay, hello and welcome to Science for Today. Thank you very much to the people who have submitted their oxidization assignment. That is great. That's going to count for one of your marks, so hopefully you guys did well. And I haven't marked them yet, but I'm going to do that after I'm done making this lesson. Okay, so let's see here. Okay, so these are the people who have done it, 17 people. I'm just going to give some Class Dojo points quickly. So we have Malik, okay, Ada's done, Alex, Ali, Amber, DR, Daisy, Daniel, not yet, Eva, Fassi, Hasham, good job, Jordan, no, Maddie, Malik, Matha, Mohammed, Quinn. This is great, guys. Rami, Rita, Ryan, and Sayun, and Zaha. Yay! Well done. That's excellent. Science task done. Okay, excellent. So if you haven't done that, then maybe you stop right now and then do that so then it's done before we have the next thing. Please and thank you. It shouldn't be too hard to do. Okay, now, okay, so the experiments from yesterday, we're going to talk about those when we come to our Zoom. So you did not, they were optional. Yes, you did not have to do them. Today, what we're doing is we're learning about the next property of air, okay? So we have two more properties left, one that we're doing today and then one that we're doing tomorrow. So hopefully on your page, properties of air, you still have space, or maybe you're just taking up more space to just write down a couple of notes. We have a few videos today, and yeah, we would be doing a demonstration in class, and like I've done this one every single year. But I don't have the tools here to do it, so I found a great video of the exact same thing. The guy is really funny doing it. Okay, so here we go. All right. Okay, so property of air number 3 is air has mass and weight. Okay? Alrighty, so here we go. Let's explain this a little bit more. So first of all, what on earth is the difference between mass and weight? And we're going to watch a video on this as well. But this is, I would like you to write this down. So this is like one of the main only things that you have to write down today. Mass is a measurement of the amount of matter that something contains. So as we learned from yesterday, air does have matter, right? It's nitrogen and oxygen and a little bit of trace gases. So it does have matter, even though we can't see it. It's like molecular, we can't see it. So the mass of an object does not change. That means the amount of particles that are in something are the same, regardless of where you are, okay? Now, weight, on the other hand, is the measurement of the pull of gravity on an object. So that means the weight does change based upon your location. So I have a video, but as I learned last time, when I have these in videos inserted and then I play them, YouTube recognizes it and then it says block. So I hope that I can do this. Okay.
Our sun
Let's
is
see if
massive.
this works.
My New Year's resolution is to lose weight. We use these words and phrases practically every day, but what is the difference between mass and weight? The answer is extremely simple, but most people don't actually know what it is. Let's get the scientific physics definitions out of the way first, then we'll discuss what they actually mean in normal people terms. Mass. Mass is a physical body's resistance to acceleration when a net force is applied. Okay, what does that mean in normal people terms? First things first, a physical body is just a fancy name for a collection of matter or stuff. So a physical body could be a planet, a galaxy, a vase, or a puppy, whatever. Next, acceleration is just a fancy way to say how quickly something changes its motion. And last but not least, a net force is just the entire force affecting this collection of matter. So we could rewrite the definition of mass to say how much a collection of stuff can stop itself from changing its motion when something else is trying to
Okay,
move
you don't really need to know
makes
that.
more sense, right?
It's a little bit complicated.
So then what is weight? According to physics, weight is the force exerted on a body by gravity. Normal people terms, please. In other words, the Earth is constantly trying to pull everything near it down towards its center. That's how gravity works. And the more mass or stuff something is made of, the more stuff gravity can pull on. Therefore, the stronger the force of gravity gets. So using our two normal people definitions for mass and weight, let's think about an example. Imagine a semi-truck parked in front of your house. Now imagine trying to push that semi-truck down the street. Basically impossible, right? But why? Most people would say it's because the semi is just too heavy, which refers to its weight, but that's not totally true. Actually, the semi simply has too much mass, or is made out of too much stuff. And you pushing on it, aka the force acting on it, is simply not enough to change its motion. So the semi's mass makes it difficult to push down the street. But now imagine if somebody told you to lift the semi-truck off of the street. Also virtually impossible, right? But why? The semi-truck, a recognizable collection of mass or stuff, is constantly being pulled to the center of the Earth by gravity, which is considered to be its weight. So your attempt to outdo Earth's gravity by lifting the truck away from the Earth is truly an attempt of lifting the semi-truck's weight. Now think about this one for a second. When you visit other planets, you're always made of the same amount of stuff. Your mass never changes, but every planet you visit has different gravity, so your weight changes.
Bingo. That's the key thing.
You can check what your weight would be on other planets at astronomate.com.
Okay, you can do that. Cool.
So what is the difference between mass and weight? Mass is simply how much stuff or matter something is made out of, and therefore how hard it is to move or change its motion. And weight is how much that collection of mass or stuff is being pulled down by the force of gravity. So now you know the technical difference between mass and weight. And as a result, you are officially smarter than most human beings on planet Earth. Now go forth. Push and lift something made from a lot of stuff resting on a table at a dinner party and officially become the most interesting person in the room. Booyah!
All right. Okay, cool. Nice. Thank you, dude. Okay. Good. All right. So I hope that helps explain that a little bit. But the key thing is this, okay? That there's so many different technologies today. Okay. Yes. So mass is the amount of stuff that something is made of, and then the weight is what's being pulled. Your weight is what's being like the force of gravity impacts your weight. That's why we would say we are weightless if like astronauts go into space, but they still have a mass. Okay. All right. Now I have another video which we're going to show, which again shows. I think this is it. Oh, okay. You know what? Yeah. Okay. Okay, let me just see here which one this is. Oh, yeah. Okay, that was it. Yeah. Okay, that was our first one. Okay, yeah. Sorry. All right. So the next thing is, okay, so thinking about this, if we were in class, we would talk about, okay, so why are the lower pancakes flattened? Okay, so if you see here, right, they're squished, and these nice fluffy ones on top are nice and puffy. So why do you think that is the case? Okay, what is actually happening there? So we would talk about this. What do you notice? Okay, then probably what we would sort of think about is, well, there is weight, right? There's weight, and all of these things also have mass. But the more things that are stacked on top of it, then of course, the more weight that is pressing down on those molecules. So it's kind of a similar concept to air. The more, like, the higher that you go, I guess, like, ultimately, like, into space, then there's, like, less particles that would be pushing down on you. So, so the, like, basically, like, at sea level, there's the most amount of air molecules above somebody, which would be pushing down on them. Okay, that's just, like, a little kind of thing to get you thinking. Okay, now next is how much, oh, I did not mean to put that one in there. Okay, I'm going to post this one too. He just talks a little bit more about mass versus weight in a cool example. I'll post this one for you guys to watch, but I don't want us to watch it as a class right now. It's kind of the same concept. Okay, now this one. Okay.
Hey, I have a question for you. How much does air way. This might sound strange because air doesn't feel like, well, anything. It surrounds us. We inhale it to stay alive, but we pretty much ignore it most of the time. Air is still made of stuff. All of the molecules that make up air, like nitrogen, oxygen, and carbon dioxide, all still have mass. So it must weigh something. But how much is something? Let's think of it this way. Imagine a 1 centimeter squared column of air. That centimeter square column of air stretching from your head to space would weigh 1 kilogram.
Can you believe it?
All of the air above you. Well, that pressure is the equivalent to the weight of a small car pushing down on you all the time. To demonstrate this, I have this strange contraption.
Okay.
It's called
so
a
I'm not going to play the rest of this now, but I am going to post that for you guys to continue watching on your own if you want. He goes through kind of cool experiment. So the one thing that I would like you to write down is, he just said it, is how much weight, if you were to draw like a little centimeter squared on your hand, which is basically like the top of your pinky, if you were to draw that on your hand, how much weight of air is pushing down on 1 centimeter squared? He just said it. Did you get that? It was 1 kilogram. 1 kg is pressing down on 1 little square only on your hand. So as he just said, like the amount of air that's pressing down your whole entire body is equal to like a car, which is crazy. So the reason, and he goes into this, I suggest that you do watch the video. I just don't want to play the whole thing. I'm worried about YouTube blocking this video that I'm trying to post, because it did that before to me. Is he's going to explain further about why we're not crushed as humans. And the reason is because we also have air inside of us that's pushing out, and we have other fluids in us as well, like our body's mainly fluid. So that's also pushing out, and our bodies are able to then kind of adapt. He does a cool experiment, which like I'd like you to watch. He puts this marshmallow man there. He puts this marshmallow man into this chamber, and then he takes out all the air, and then you could see what would happen. So that's also like gives a little bit of background for like when astronauts go into space, they have to wear a spacesuit, or else like crazy, like truly like out of the spaceship, if they go just into space, then it wouldn't be good for their bodies. And he kind of explains why that's the case, which is cool. Okay. Now, next is, now this, if we were in class, we would be doing this lab or kind of like demonstration. It's a little bit tricky to do, but if you have these tools, you could try this at home. It's totally optional though. Okay, so how can you demonstrate that air has weight? Okay, so basically what we're going to do, or what this video is going to show, is we're going to have some type of like, I don't know, what I've done in the past is just like had this ruler, and then, or a meter stick actually works best with a meter stick, which I don't have, or like a broomstick or something that has to be like even. And then you have 2 balloons that are the exact same size of the balloon, and then ideally also blown up to the same amount, which is like really tricky to actually get. And then a string to attach the balloons to each end of the stick, and then you have to like balance it. So the question is, what is going to happen? Like how can we use this to demonstrate that air has weight? So the prediction is, how do you think this can be demonstrated using these like very simple tools? All right, let's watch. Okay. This is very funny. This guy is just so into it. Okay.
Hi, I'm Jared, and welcome to Science Demonstrations for Young Learners. I have my hands full here because our big idea is quite interesting. The big idea is that air is matter and air has weight. Science tells us that air is matter and air has weight. So how do I show you that? Welcome to my scale. I have a neat balance here that almost is balanced. Hey, it's working pretty good.
It's tricky to do this.
I have 2 balloons, and I want to show you that air has weight, so I put air into them. So what I'm going to do is I'm going to remove the air from one of these balloons. We're going to go with this one right here. So if I take the air out of this balloon and this balloon still has air, it should be heavier. Let's see if we can get this to work.
Once I did this and popped the balloon,
Okay,
which totally
I've removed the air.
didn't work.
It's slowly leaving the balloon. Whoa, it's swirling because I get a force. Pushing on my scale. I'm gonna stabilize it just a little bit and watch.
What's gonna
the science
happen?
Happen. Wait a second. It's spinning. I'm gonna stop the spinning. Oh look! This is heavier. Why? There's air in it. There's no air in this. Air, no air. Air actually has weight. It's heavy. Science is cool. Thanks for watching.
There you go. Okay, I love it. That was actually so well done. And yeah, really clearly shows that air
I'm Jared.
has...
Welcome to Fun Science Demos. Today we have a little
Okay,
bit of
John.
a science.
Thank you. Okay. Yeah, so anyway, that really does an excellent job showing how air has weight. And it's kind of like mind-boggling because you don't think that it actually... And you saw how much of a tilt that the ruler or the meter stick went onto, right? And like that was just a little balloon. And it was like really different. And there was no amount of balloon that was lost. He didn't pop it. The balloon pieces didn't go flying anywhere. So it truly was how much weight that air actually has. So again, just write that down. Maybe you want to draw this. You could do this as like a very visual way. And the key thing is that 1 centimeter square on your hand has how much weight? I can hear you saying 1 kg, which is crazy. Okay, that's it for today. You don't have to do anything. Just write down those little notes and then that's it. Ta-da! Okay, good job.